Many scientists are still determining whether AI will ever completely replace human researchers, despite scientists' continued embracing of its promise. Many hazards and difficulties are associated with using AI in scientific research, including the possibility of bias in data analysis and issues with ownership and management of data. AI also has the potential to revolutionize how we do scientific research and hasten the advancement of disciplines like climate science and medicine. Is AI then the science of the future? The solution is intricate, requiring careful assessment of the benefits and drawbacks of this quickly developing technology. While utilizing AI in science has the potential to revolutionize scientific research, it also comes with several hazards and problems. A future that maximizes the potential advantages of AI while minimizing the risks must be created. Scientists, politicians, and society must carefully assess AI's possible consequences on scientific research. By doing this, we can ensure that AI is used in studies to advance knowledge rather than pose a danger to those fundamental principles. The possibility of losing their jobs and the evolving nature of their responsibilities in the scientific process are two of scientists' biggest worries. Many jobs formerly carried out by human scientists, such as data processing and even hypothesis formulation, are currently being automated by AI. The number of jobs for scientists may decline, and more technical and computational positions may replace them. Additionally, the importance of human scientists in the scientific process may diminish as AI systems become more sophisticated and capable of handling complicated tasks. This raises concerns about the relevance of human intuition and creativity in scientific discoveries. The possibility of bias in AI systems utilized in scientific research is another issue that worries scientists. If the data used to train an AI system is biased, the system will reinforce that bias because AI systems can only be as impartial as the data they are trained on. This might result in AI-generated outcomes that validate pre-existing prejudices or discriminatory behaviors. In addition, the application of AI in scientific research creates significant ethical concerns, particularly concerning data privacy and informed permission. The application of AI to scientific inquiry also calls into question who owns and controls scientific discoveries. Who is the rightful owner of AI-based scientific discoveries? Which party is at fault? The scientist who created the AI system, the person or group that instructed it, or the scientist who applied it to a particular problem? These inquiries, which still need to be addressed entirely, bring up significant moral and legal issues about intellectual property rights. Additionally, there are significant concerns regarding the democratization of science raised by the potential for AI to automate scientific discovery and study. The cost of scientific research may decrease if AI systems grow increasingly competent in completing challenging scientific tasks, making it more available to people and organizations that previously would not have had the resources to do research. There is also a chance that discoveries made by AI will be used to support current power systems rather than undermine them. The application of AI in scientific research has a lot of potential advantages, notwithstanding these worries. Large volumes of data can be analyzed by AI systems more rapidly and precisely than humans, making scientific research more productive and efficient. AI can also develop new theories and insights that human scientists might not have seen, leading to new findings and breakthroughs. Much of scientific research's laborious and repetitive work can be automated using AI. They allow scientists to concentrate on more original and creative projects. In several ways, AI has the potential to improve scientific research significantly. The use of AI in drug discovery is one instance. AI can drastically speed up and cut costs in the time-consuming and expensive drug discovery process. Many data can be analyzed using AI to find possible medication targets, which can be tested in a lab. This can significantly reduce the time and resources needed to find prospective drug candidates, enabling researchers to develop new medications faster and more affordably. The discipline of materials science is another area where AI is having an impact on scientific study. An interdisciplinary field called materials science investigates the characteristics of materials and how they might be applied to the creation of new technologies. To forecast material properties and discover new materials with desirable qualities, scientists are using AI to model the behavior of materials at the atomic level. This can significantly speed up the search for novel materials and pave the way for creating previously unimaginable new technologies. It is also used in novel and creative ways to analyze scientific data. For instance, AI can analyze telescope data to find new planets or galaxies. This can significantly improve our understanding of the cosmos and result in novel astronomical findings. In disciplines like genetics, AI may also be used to analyze big data sets, resulting in fresh deals of the genetic underpinnings of diseases and the creation of novel therapeutics. Despite these potential advantages, using AI in scientific research also carries some hazards. The possibility of bias in AI systems is one of the biggest threats. Only the data used to train AI systems can guarantee their objectivity. Furthermore, if the data used to train an AI system is biased, the system will maintain the bias. This might result in AI-generated outcomes that validate pre-existing prejudices or discriminatory behaviors. The possibility of employment displacement is a danger related to the usage of AI in scientific research. The demand for human scientists may decline as AI systems perform complicated scientific jobs more efficiently. The number of jobs for scientists may decrease, and more technical and computational positions may replace them. Working collaboratively to create ethical guidelines and best practices for the use of AI is crucial if scientists and policymakers are to minimize these hazards and maximize the potential advantages of AI in scientific research. Ethical concepts, including respect for human dignity, non-maleficence, beneficence, and justice, should constrain the use of AI in scientific research. This involves ensuring that AI systems are transparent, answerable, and unbiased. The evolution of scientific collaboration is another potential effect of AI on scientists. Researchers can now more easily collaborate across geographical and disciplinary borders thanks to the growing usage of AI in scientific research. AI may analyze massive datasets and spot patterns and trends that human researchers might miss, enabling academics from several disciplines to collaborate on challenging challenges. However, the growing use of AI in scientific research has the potential to alter how scientists collaborate. The demand for conventional collaboration may decline as AI systems become more sophisticated and capable of handling complex tasks. Instead, researchers might rely on AI systems to handle many labor-intensive activities, freeing them up to concentrate on more specialized work. This can cause the skills and knowledge that the scientific community values to change. For instance, researchers with programming and data analysis expertise may discover that their talents are more in demand. At the same time, those focusing on conventional laboratory methods may find that their expertise could be better. A change in how scientific research is funded and carried out may also result from the growing usage of AI in this field. For instance, supporting research that significantly relies on AI may not fit conventional funding models, necessitating the development of new funding models. Similarly, it might be necessary to modify the peer review procedure to consider the growing usage of AI in scientific research. Last but not least, AI has the potential to alter how scientific findings are shared and propagated. Data and results sharing throughout many fields and specialties may become more straightforward with the growing usage of AI in scientific research. This can result in fresh insights and discoveries, but it might also result in an overabundance of confusing research. The possibility of bias in data analysis is one potential concern of AI in science. Because artificial intelligence systems are only as good as the data they are trained on, partial or incomplete data may provide limited outcomes. This is highly troubling in industries like healthcare, where AI is rapidly being used to analyze patient data and make therapeutic judgments. AI that has not been adequately trained or validated risks providing patients with harmful diagnoses or treatments. The potential for AI to automate scientific discovery is a further cause for concern. While AI can undoubtedly help scientific research, it may eventually supplant human researchers. This might have significant ramifications for the scientific community and society. For instance, conventional scientific professions may lose knowledge and jobs if AI replaces them as the primary tool for scientific discovery. While utilizing AI in science has the potential to revolutionize scientific research, it also comes with several hazards and problems. A future that maximizes the potential advantages of AI while minimizing the risks must be created. Scientists, politicians, and society must carefully assess AI's possible consequences on scientific research. By doing this, we can ensure that AI is used in studies to advance knowledge rather than pose a danger to those fundamental principles.